right, so we're going to pick up where we left off from last time with polar coordinates. And what we're going to work on today, last time we sort of worked on the idea of figuring out where we were in terms of r and theta when I had a particular point. And either plotted that point or found another value for that r theta component. Today we're actually going to work on changing between rectangular, which is the system that you know and love all the way back to somewhere probably like, I don't know, 6th, 7th grade, something, and into this new system of polar coordinates and backwards. So we're going to go both directions with that today. All right, so this first one we're going to do is we're going to take a polar coordinate, the one that we're working with new, and figure out how we change it back into rectangular coordinates, the ones we know and love. And these are actually the two equations for them, and they should look vastly familiar because we've encountered these equations before. And we encountered them from a perspective of a unit circle. So when we were dealing with, well, actually not even a unit circle, but a circle in general, when we're dealing with a circle, change this color. All right. Oops. All right, imagine that that's a circle and it's centered on there. It's not, but I'm going to have a difficult time getting it to, we'll try one more time. Oh, that's pretty good. Okay. All right, so if you imagine a point on the circle, let's take this point right here. And you want to know the x-coordinate for that point. There's a relationship between sine and or cosine and the x value and the radius of the circle. So if you take the radius of the circle, like this, and you make a triangle, then x is actually the distance at the bottom of this triangle, right? This would be the x distance, this would be the y distance, and this would be the r, the radius of my circle, and you know wonderful trig functions related to that, right? This is a right triangle. So sine of theta, in other words, is the opposite, which is y, over the hypotenuse, which is r, and if you solve this, you see that y equals r sine theta. And the same thing for x. So these are coming from equations you know, all right? And again, I mentioned this once before, but let me reiterate it one more time. I had a student once talk about how that she remembered that x was cosine and y was sine. Do you remember what I told you? You may remember it. They're alphabetical order. So cosine comes before sine in the alphabet, CS, right? And then x comes before y in the alphabet. So that's actually how she remembered it. We've been dealing with it at this point for quite a while, so probably you just remember it. But these are what we have. So what we're going to do is we're going to take an ordered pair. It is a polar coordinate, right? Which means what is that 3 representing in this, sorry, this negative 3 representing in this ordered pair? What was that? Right, and that's called, we call it the radius, right? It's the distance from the origin. And if we were plotting it, it would be moving left 3. So we'll plot it to make sure that we're understanding and we're getting the same value when we're done. But we believe that this is going to move us left 3. In fact, this point should look familiar. We've seen it before. We saw it last class. And then we move in the positive direction because the angle, theta, so this is r, and this is theta. The angle theta is positive, so we move in the positive direction, and we find out that our point is actually here. And we know what the ordered pair is for that point. What is the ordered pair in rectangular coordinates for that point?
3, 0.
It's actually 3, 0, where 3 is x and 0 is y. Now, we're going to use the formulas to verify that they actually are giving us that value too, because they will, and I want you to see how you would use them if you didn't end up with a nice, wonderful value on a quadrantal angle. It's great that we ended up on an axis. It's easy to see. But what happens if we don't? Well, these formulas work really well. So my x value is found by taking r cosine of theta. R is negative 3. Cosine and theta is pi. All right, so what is cosine of pi? Close, that's sine of pi. Negative 1 on cosine, yep. We'll get to the sine one in a minute though, Erin. And then what is the value here? 3, because I have negative 3 times 1. Okay, so x is 3. Let's do y. Y is r sine of theta. So r is negative 3 again. Sine, and theta is pi. And then sine of pi is 0. That one is 0. And then we end up with y equaling 0. And as you can see, of course, that gives us the ordered pair 3, 0, which I understand we were able to do that visually on this one, but it's always nice to know that the formulas worked. Because I'm telling you they work, I should show you that they work, and they do. So we end up with 3, 0. I think my next one doesn't end up on a axis, so it's a little bit more helpful to work with the formulas on it. Same pair, right? We've seen this ordered pair before. We saw it on problem number 2, we saw it on problem number 4, and now we're seeing it on problem number 6. Directions are different. It's find the xy coordinate pair. Now, we actually know what quadrant it's located in. What quadrant is it in? 4. So one of the pieces of information that will be helpful to know, just an checking kind of an idea in our mind, is down in quadrant 4, is x positive or negative?
X is positive.
X is positive. How about y?
That would be negative.
That one would be negative. So when we're getting our x and our y values, we better be getting the right sign on them, or we've got something else going on that's causing problems. Everybody with me on that? Okay. All right, so we're going to take our formulas, which are x equals r cosine of theta. What is r? 6 cosine, and what is theta? Negative 60 degrees, which means you might have to pause and think about. Well, it is 60, that's true. And why is it 60, Lauren? Because of the odd even properties for cosine, and cosine is what we call an even function. So a negative on the inside is the same as a positive. That's a good point. So we can actually deal with that one pretty well with the negative. All right then, so what is the cosine of 60 degrees? It is, it's 1/2. Good. This one's 1/2. Cosine's 1/2. Yeah. Okay, so then what's 6 times 1/2?
3.
3. Awesome. So we've got 3. So that's x. Let's find y now. Y is r sine of theta. R, as we established, is 6, and theta is negative 60. Let's use those even odd properties again. What will this change to without the negative inside with sine, inside of the sine? Right, the negative can come out because sine is an odd function. So this one comes out in front, negative 6. All right then, what is the sine of 60? That is radical 3 over 2. And if I simplify, what do I get here for y? Okay, so negative first, right, Lauren?
Right.
And then what do you have? Did you say 3 square root of 3?
No.
Okay. So the 2, in other words, down here, and this 6 reduce and give me 3. So again, don't get carried away and think you're finished. The question was for the ordered pair to show up. The ordered pair is 3 and then negative 3 square roots of 3. We all good? Okay. So that's moving from polar coordinates back into the rectangular coordinates that you know and love. And sure enough, we found out on this particular one, positive for x, negative for y. So that sort of helps confirm that our picture matched our thinking, which is good. And we're going to have to be able to actually go the other direction as well. So now we want to be able to take rectangular coordinates, okay, the ones you've been used to for the last 10 years or so, maybe not quite that long, and then turn them into polar coordinates, okay? So we're turning them into this new system. And you see I have 2 other equations. And again, they're equations that you have seen before, right? X squared plus y squared equals r squared. What is that? That's Pythagorean theorem. And the reason it's r is because we're talking about the radius of a circle. It's the hypotenuse, the same thing, right? C squared. Tangent theta equals y over x. Have we seen that? Oh yeah, we've seen that all kinds of times, right? Of course, sometimes we describe it as sine x over cosine x, or sine of theta over cosine of theta as well. But this is another way, right, y over x, that we've seen it. So these are familiar formulas for us to use. And these formulas will allow us to change it the other direction, okay? So we're going to take an ordered pair we haven't seen. This is a new problem. Brand new. Isn't that exciting? Absolutely. And we have to remember which one we're working in, so make yourself a note that right now they gave us a value that's xy. Okay, this could be an r theta value. You have to make sure you know where you're starting and where you're ending up. Just because you don't see a pi or you don't see a degree symbol does not mean that it's not an angle. You guys remember that? It's been a long time since we've seen that. But 3 actually could represent a radian value, the second value here, the 3. So you need to make sure where you're starting and where you're ending. This one is xy because it says it's a rectangular coordinate. Okay? All right, and we're supposed to find the polar coordinates. So to find the polar coordinates means I need to find r and I need to find theta. And these are actually a little bit more difficult to find than the last ones because if you notice these equations here, they do not say r equals and they do not say theta equals, right? So the solving of them actually involves a little bit more work. But in order to find r, the first formula is the one I need to use. X squared plus y squared equals r squared. Okay? So I've got x squared plus y squared equals r squared. And x is -3. Make sure you understand that it's the negative that's also squared there. It's not just negative and then 3 squared. It's -3, quantity squared. Plus, and then I have 3 squared for y equals r squared. So what is -3 squared? 9. And 3 squared? 9. And then I'm supposed to add them, so I get 18. Be careful. I'm not asked for r squared. I need to find r, which means I need to square root. And it is not okay to leave this as square root of 18.
3 squared 2.
Right. This is 9 times 2 underneath a square root, right? So this is actually 3 square roots of 2 for r. Okay. Now you have to be a little bit careful because actually I could have put a plus or a minus on that when I took the square root. And that's actually okay because if you'll remember again as well, when I do polar coordinates, there's lots of polar coordinates for every point in the unit, right, or in the axes. So we just want to make sure when we're done we're in the right quadrant on this. What quadrant is -3, 3 in?
2.
2. So here's -3, 3. I should be up here somewhere. So right now, 3 squared root of 2 is fine, but let's just keep that in mind that we want to make sure that when we're done, we don't end up telling me that I'm supposed to be in quadrant 1 or something like that. Okay? So, in fact, you know what? Let me put a plus or minus just to remind ourselves, and we'll come back to that idea. Theta, though. Theta had another formula, right? About tangent. The formula I have for theta says that the tangent of theta equals y over x. So I don't know theta, but I know y and x. What is y? 3. And x? So tangent of theta is actually equal to -1. Tangent and cotangent values that are 1s and -1s always occur where? At the 45-degree angles. And unless the problem tells you otherwise, you can give your answer in degrees or in radians. Okay? I suspect my math lab will probably be specific because it needs the answers entered a certain way, but I don't think your homework is specific, so you can do either option, okay? Unless it says you can choose. So Lauren said degrees when she described it, so we're going to go with degrees in this particular problem. So where do I get a tangent value that's negative? Which quadrants? 2 and 4. So I need to look in quadrants 2 and 4 and figure out which two 45-degree angles my options are, and I actually know what quadrant I want to be in. I want to be in quadrant 2, so I might as well give the answer that's in quadrant 2, right? Yeah. So what angle in quadrant 2 gives me the tangent value of -1? 135. And if you had done it in radians, what would you have said? Do you remember? 3 pi over 4, that's right, very good. All right, so because the quadrant will actually, because my angle will actually get me there from the positive x-axis, I'm going to use the positive part of the r value I found because that will get me out, I go out the distance of 3 square, let me do it from the perspective. I go out from the origin the distance of 3 square roots of 2, and then I can rotate my angle over here to 135. Is that making sense with my hand waving and such? All right, so my ordered pair then is 3 square roots of 2, 135. Now, pause with me for a moment and consider how else could I write this? What other angle could I use? Or not angle, but what other ordered pair could I use that would actually also do this? And one easy way to do that is to say, what if I really chose to do the negative 3 square roots of 2? What could I do? Negative 45 would work. You bet it would. So remember what this does. I'll use a different color here. Let me use this. Let's try yellow. Negative 3 square roots of 2 would put me somewhere over here. Right? And that would mean I need to go backwards to get up here. Hence a negative angle. And how much does that angle need to be? 45. So we could express it like this and it would be just as good, right? So on your homework, I don't care which way you express it, right? But what I want you to recognize is that if you flip to the back of the book and they get something different, it doesn't necessarily mean you did it wrong. So be on the lookout for that. Check and make sure that your answer and their answer actually put you in the same spot. If they do, then you're fine with whatever answer you have.
Could you also say T?
You could. So you could do the negative 3 square roots of 2, and then you could go around in the positive direction, like so, right? And then it would be 315 degrees. You bet. And there are other options as well, of course, right? We've got infinitely many choices that we could do here, and any of them are fine. Okay? So if you want to get really creative, this is your opportunity to be creative. All right, this is a question that's a little bit different. You notice there's not an ordered pair here, right? I don't have x comma y or r comma theta. I don't have an ordered pair. But I do have an equation, and the equation that's given has x's and y's in it. Make sense? Okay. Now this equation has a graph in the xy axis. I can draw it. Actually, if I drew it, it would look like a parabola that opens sideways. That's what this would look like, okay, if I actually were able to draw it completely. But the question here is asking you to write this equation as a trig function instead. So instead of having it with x's and y's in it, change it so that it has r's and thetas in it. And actually, as I'm thinking about this, I want to make a comment. Your calculators graph in polar coordinates too. The ones that you have, those of you who have the graphing calculator, so I'm looking here at Ashland's. So if you have a TI 84, 83 kind of calculator, and you go underneath mode, you can change your mode to graph in polar. So if you're interested in kind of taking a look at it, you get really cool graphs in polar. Your graphs in the XY plane are very not interesting, but you can get flowers in polar mode. There's some really cool stuff you can do. So if you're interested in giving your calculator to a small child and letting them play with it, change it into polar. They'll have more fun. Okay? All right, so let's take this one and change it. So we're going to change it with the formulas we know. So in place of y, I need to write what y is equal to. So what is y equal to from what you saw in your equations?
R sine theta.
So this would be r sine of theta. And since y is squared, r sine of theta is squared. So far, so good? Okay. And then I have 2, and then I've got x. What is x in terms of r and theta? R cosine theta. We're going to clean it up a little bit. We're going to go ahead and distribute that square. So that square, because this is multiplication, has a distributive property. This is r squared sine squared of theta. On the right-hand side, we have 2r cosine theta. Do not be tempted to cancel out the r's. That is inappropriate. You don't want to cancel a variable out ever. You lose solutions when you do that. However, I believe your book will most of the time take these and put them on the same side of the equation. So you're probably going to see the next thing is writing this as subtraction, like this. Or you could do the subtraction to the other side. That'd be fine too. So this is the cleanest and the best that you would get to at this one, and it satisfies the equation or the directions it said. Write the equation using polar coordinates, and we did that. Make sense? And you could check this in your calculator. You could take your calculator. Unfortunately, the first equation is written as y squared, which means if you wanted to check this in your calculator, you would have to solve this for y, which means you get y equals square root of 2x and y equals negative square root of 2x, and you'd have to graph them in y1 and y2. And if you did, you would see a sideways parabola, okay? You have to graph it in pieces. And then you could change your calculator into polar coordinates, but the problem then is going to be that you have to solve this equation for r. And if you solve this equation for r, you could graph it as well, and you could see that it also will look like a parabola. Okay, not a flower. Flowers come out in other places, but okay. All right, and we want to go the other direction as well. All right. We want to be able to take a equation that's written with r and theta and write it in terms of x and y. Now, unfortunately, and this is the hardest direction to go, I do not have equations that say r equals blank. Theta equals blank. I did those for x and y. I have those. So changing it from the direction of x's and y's into r's is the easier direction to go. This is difficult because I don't see r. I don't see thetas. But I can change some things so that they would look like that. So any suggestions? Anybody see anything that you could do or that you might like to try? I may not have an equation for r equals, but I do have an equation that has r in it. What do I have?
R squared equals X squared plus Y squared.
So I have an r squared equals x squared plus y squared. So what's r? It is an x plus y.
Square root of X squared plus Y squared.
Yeah, you can't undistribute or distribute, or however you would say that. You can't distribute, I guess you'd say, square roots to squares in between. It doesn't work. And let me just give you an example because it's a really common mistake. If that were possible, then it would have to be true that when you take 3 squared plus 4 squared, you get 7 squared. What's 3 squared? What's 4 squared?
16,
What's 7 squared?
49.
Is 9 plus 16 equal to 49? No. So you can't just distribute a square root. Okay, it's not a possibility. So what you can do, though, is you can leave the square root there. So over here, I can express r as the square root of x squared plus y squared. So I can write this as the square root of x squared plus y squared. I've got other issues. I don't actually have an equation that says sine theta equals, but I've got one that nearly does. What's an equation I have that has a sine of theta in it?
Y equals
Y equals
R sine theta.
r sine of theta. So what does sine of theta equal?
Y over R.
Y over r. Now that isn't exactly what I want because it's still got r in it, but it's okay. We'll deal with that in a minute. I can do the same thing with cosine. So if if y equals r sine theta, then x equals r cosine theta, right? So what's cosine of theta? Exactly. So I can write this as x over r. I can combine those, right? Because they have the same denominator. So I could write this as y minus x over r. And I've got the square root of x squared plus y squared on the left. And I've got another r in my problem, correct? But what is r equal to? Now, technically, we have solved the problem, but the cleanup requires just a touch more. You notice there's 2 square roots in here, right? Mm-hmm. And one of them happens to be in a denominator, and we don't particularly want to leave something that's square rooted in the denominator anyway. But it would be awfully nice if I multiplied by the square root of x squared plus y squared on the right, because they cancel, right? And it's actually almost equally as nice to multiply them on the left, because what happens when I multiply the square root of x squared plus y squared times the square root of x squared plus y squared? It cancels out what?
Square root.
The square roots. So I'm actually still left with the part underneath, which is x squared plus y squared, but there are no square roots. So I have x squared plus y squared equals y minus x. And again, typically speaking, when you have an equation that has squares in it, we factor everything, or we, sorry, not factor, but we move everything to the same side because often the next thing we will encounter has to do with factoring things. So we're going to do one more step to move everything over here to the left. So I would have x squared, and you can write it in any order, so I will, plus y squared, and then I'd have minus y, and I'd have plus x. Is everybody okay with that? Does it make sense? All right.